and the girls. Good morning. Yeah. Mrs. Ndiko, as you have heard, I'm going to present physics paper 2. I'm going to present physics paper 2, as you are aware. So I think we can start. For physics, we have 3 papers, just like any other science. We have paper 1, paper 2, and paper 3. Paper 1 and paper 2 each contains 2 sections, section A and section B. Section A carries 25 marks, short questions, a maximum of 3 marks, while section B carries 55 marks, structured questions.
As for physics, we have the topics divided. We have topics for paper 1 and we have topics for paper 2. For me, we have the paper 2, so we are going to start by seeing the topics for paper 2. I'm sure you know the topics learned from Form 1 up to Form 4. So we are going to have the topics for paper 2, and those are the topics for paper 2. Starting from Form 1, we have the first topic, that is rectilinear propagation of light and reflection at plane surfaces. We also have reflection of curved mirrors, that is in Form 2, and diffraction of light and in lenses. The topics are trying to group them the way we can have the structured questions in section B, because we can have a question learning from rectilinear all the way up to beam lenses, the structured questions. Then we also have the cells and the simple circuits, that is Form 1, current electricity, Form 3, heating effect of an electric current, Form 3 also, and mains electricity, Form 4. All those deal with electricity. So we can have the structured question carrying all through from along those topics. We have electrostatics of Form 1 and electrostatics of Form 3, that is electrostatics 2. We have waves 1 done in Form 2, waves 2 done in Form 3, sound Form 2, electromagnetic spectrum Form 4. Magnetism, magnetic effect of electric current, those are Form 2, and we have electromagnetic induction Form 4. Photoelectric effect Form 4, cathode rays and cathode ray tube, that is also Form 4, X-rays, radioactivity, and electronics Form 4. So those are the topics which are tested in paper 2. So as you revise for paper 2, you should make sure you revise on these particular topics. The rest are in paper 1. When it comes to setting of the questions, we have, I've tried to group them, we have at least 5 different types of questions which can be set in the exam paper. We have the statement questions, numerical questions, graphical questions, diagrammatical questions, and then we have questions, experimental procedure questions. We are going through each one of them, seeing what is required for each type of the question. Remember, these questions can be in section A or also in section B. So we start with statement questions. For statement questions, these are questions whereby you will find the words explain, list, name, divine, state, or you can also be taught to arrange, like the electromagnetic spectrum. Those are questions to do with those words. We have an example like of 2013, paper 2. We have an example of 2013, paper 2, question 1, a statement question. The question was said, state the reason why when a ray of light strikes a mirror at 90 degrees, the reflected ray travels along the same path as the incident ray. We have the answer or the expected answer. We know the angle of incidence equals to the angle of reflection. But now here the reflected ray follows the same path. So in a marking situation, not just the angle of incidence is equal to the angle of reflection, but you have to specify that the angle must be 0. So like this question, 0 was the marking point. If you don't give the angle of incidence is equal to the angle of reflection and you mention 0, then there is no mark. So 0 had to be mentioned. That's why the reflected ray will follow the same path. When stating factors, we have questions whereby you are told to state factors. Like we can be told to state the factors which affect the capacitance of a parallel capacitor. 2 of them. If we are told to state 2 factors, then state or restrict yourself to the number of factors or characteristics which are required. And then state the factors without explaining. You also avoid contradiction when you are answering. For example, like if it's characteristics of an image. The image cannot be real and the same time virtual. So you have to avoid mentioning the 2 words when mentioning, otherwise you will contradict yourself. Also, if the image is enlarged, cannot be diminished. So when we are stating, we should try to avoid those words to contradict ourselves. When we are defining terms, this is also in the statement questions, defining terms or principles, then the key words must be used. Don't use the same word to define itself. The meaning must come out clearly. The laws and principles must be stated the way they are under the conditions which they operate. For example, if we are to state the Ohm's law, we have to give the condition under which the Ohm's law must operate. That is, when the current passing through a conductor, the current is directly proportional to the PD across, provided the temperature and other conditions are kept constant. So we have to give that condition. The same will also happen when we are stating the law of conservation of momentum. For a system of bodies, the linear momentum remains constant, provided no external force acts. So the condition must be named. If you don't give the condition, then there is no mark. The same when we are also stating the laws, like the Archimedes principle. When we talk of the Archimedes principle, that's an example, then we have to use the word fluid, but don't be specific. Don't mention water or liquids. You have to mention the word fluid. So that is when we are stating the laws and the principles. We also have a case whereby we can be taught to distinguish or differentiate between 2 things. For example, we can be taught to distinguish or differentiate between mechanical and electromagnetic waves, fission and fusion. If we are giving the explanation, it must be continuous. And if we are when we are also given 2 similar things and we are to differentiate them, we have to use a comparative term. A comparative term, these are terms like greater than, more than, less than. For example, we have this question which was there on 2018. State the reason why thick aluminum wires have referred to copper wires for transmission over long distances. Can I have someone to give me the reasons? What is the reason? Answer. Okay, when we are giving out the reason, here we are comparing aluminium and the copper. And because we are comparing the two of them, then a comparative term must be used. For example, aluminium is lighter than copper. You don't say aluminium is light, but the word lighter must be used. Aluminium is cheaper than copper. Aluminium lasts longer. We are comparing aluminium in comparative to copper, so we have to use the comparative term. State one characteristic of soft X-rays that distinguish them from hard X-rays. We know all about soft X-rays as well as hard X-rays. Soft X-rays, if we are giving the answer, like here, a comparative term must be used because we are comparing soft X-rays and hard X-rays. Soft X-rays have longer wavelength than hard X-rays. If it's the frequency, we have soft X-rays have higher frequency, have lower frequency than hard X-rays. So when we are comparing the two, a comparative term must come out. You don't use a comparative term, no mark. We have also in the statement question, we have compare and the contrast. This is whereby we can be giving difference between two similar pictures. For example, we have the eye and the camera. When you are giving the difference between two pictures, then you compare a similar thing. Like if it is the eye, we are looking at the lens, the crystalline lens. Then for the camera, we also look at the lens, which is also used there. We look at it, the comparison, looking at two, the similar thing or the picture which is common in the two things. We also have the term explain, which is also used. When you are explaining, you can be taught to explain the observation. If we are taught to explain the observation, then you give a schematic and detailed account of something. For example, we have this question. This is a common question. It appeared in 2012. It was there also last year. It was also early 20s. It's a common question if you go through the familiar. We have two identical copper coils, X and Y, placed close to DC supply, while copper Y is connected to a galvanometer. The question is, explain what is observed on the galvanometer when the switch is closed. Format. Explain what is observed on the galvanometer when the switch is closed. When we are explaining, first, you have to give the observation. What will be observed? You cannot go ahead to explain when you have not given the correct observation. If the correct observation is not given, then the examiner will not even go ahead to read what is written there next. Like this question here, we have the galvanometer deflects momentarily. The galvanometer deflects momentarily. Or you can say the galvanometer deflects and returns back to zero. the galvanometer deflects and returns back to 0. That is the observation. Then after the collector observation, then you can go ahead to give the explanation. So we have the explanation. The observation will carry 1 mark. Then the explanation will carry 3 marks. So when the switch is closed, the current increases to maximum. The magnetic flux in coil H, dealing with coil Y, will also increase to maximum, and this induces an EMF in coil Y, which will cause the current to flow, and the galvanometer deflection. A question like this one, the first thing which the examiner will do is to check whether the observation is correctly. The observation can come at the beginning, or it can even come at the end. You can explain, and at the end say the galvanometer goes back to 0. That is to say the galvanometer deflects, then you give the explanation, and at the end, the galvanometer goes back to 0. So like this one, when it's being marked, first, the examiner will say, we are the word returning to 0. If you don't mention returns to 0, then the word question will not be marked. In other words, you score 0 is the question. So the correct observation must be given. And here the keyword was explained. That's why we have given a detailed explanation of what was happening. But if it was just state, like 2012, the question was just state the observation in the galvanometer when the switch is closed. State the answer was the galvanometer deflects momentarily, or the galvanometer deflects and returns back to 0 without explanation. But if explanation is there, then you have to go ahead and explain what is happening, or what is making it behave in that manner. We have number 2 of the question. State what is observed on the galvanometer when the switch is open. We have the answer. The galvanometer deflects in the opposite direction. If you look at these 2 answers, in the first question, the student was not specific to which direction the galvanometer was deflecting. That means him or her to be safe. Because the answer says the galvanometer deflects in 1 direction. The question was not concerned with whether to left or to right. No, we do not want. But in this case, if the galvanometer went in 1 direction, then the second question, when you close the switch, when you open the switch, the galvanometer deflects in the opposite direction. And then it returns back to 0. The word returning back to 0 must be mentioned. The third question was asking, state what would be observed if the number of turns in coil Y is doubled. We are comparing before the coils were doubled. So like in this case, a comparative term must be used because we are comparing 2 things. Before, the number of turns were added. So the galvanometer, or the deflection in the galvanometer, doubles or increases, or you can say becomes greater. That shows it will be greater than it was at the beginning. So a comparative term in that case is important. We have the second types of questions, the numerical questions. The numerical questions. When it comes to the numerical questions, all working must be shown, no matter how simple they might be. If working is not shown, then you might not score a mark. When you are writing formulas, the correct symbols must be used. For example, we have this formula which is normally an issue in paper 2. Frequency F is 1/T. It's good to take note when you are writing F. It must be a small f, not a capital F. If you use a capital F, then it's wrong. So you have to use a small f. After writing the formula, proper substitution with the correct units is done. Then it's also important to know the formula. When we are writing a formula is an equation but not an expression. So don't give one part of the formula. It's good we give all of it. Then it's also important to note that answers should not be expressed in fractions unless required. Answers should be expressed in 4 significant fingers or at least 2 decimal places. An example of where we can have an answer expressed in fraction is like in the transformers. You can be asked to give the ratio of the number of turns in the primary to the number of turns in the secondary. In that case, it must be a ratio. But unless a case like that, any other answer which is calculated must always be left in decimals, leaving 2 decimal places or giving the answer at least 4 significant fingers. When it comes to a question of 2 marks, the formula or the working is awarded the first mark, then the other mark goes to the answer. If we have a question involving 2 formulas, then the mark is awarded to the final formula or the formula leading to the mark, and then the other answer will go to the other mark will go to the answer. For a 3 marks question, the first mark goes to the formula, the second mark goes to substitution, and then we have the last mark going to the answer. When giving answers, the answer must have correct units. If the answer has correct units, it earns 1 mark. An answer with wrong units, no mark. An answer with no units will earn 1 mark. That means it is better to do the answer without units. We are not sure of the units, other than writing the wrong units. Because you end up by scoring half a mark, which might be at the end be of beneficial. In the case you give 2 answers, this one is treated as a contradiction. So you have penalized a mark. If you give 2 answers, leaving for the examiner to choose which answer is correct, you will be subtracted a mark. We have what we call in physics the transfer. This is whereby it encourages candidates not to leave any questions unresponded, especially where we have subsections. If we have a wrong answer in the earlier section, that wrong answer and it is used collectively in the subsequent section, then we'll end up by earning all the marks. For example, we have that wave which is drawn there. From the wave, we can get the period. We have the question. Determine the frequency of the wave. Then after that, we have to get the velocity of the wave. So if we are getting the frequency of the wave, I have to explain the wave. We have seen the way it was. So like the first part was to calculate the frequency of the wave. So from the wave, we have T. We have T, we have the period T from the wave was 20 seconds. Let's say a student, instead of getting 20, assumes the period was 10. So uses T as 10 instead of 20. And comes ahead and says F is equal to 1 over T. That is the formula. Substitutes F is equal to 1 over 10. That was his period. This ends up getting 0.1 as. That will be the frequency. This question was 4 marks. So the student will get the answer wrong, but you'll get a mark for the formula. That's 1 mark. Because the period was wrong and the calculation was wrong. But we have the subsequent question part, which was asking the frequency, the wavelength, the velocity of the wave. So we come and now use this answer, 0.1, in that other question. That other question was 3 marks. That first part, you got 1 mark for the formula. But now the second question, velocity. Velocity is equals to lambda f. Velocity will be equal to, we are calculating the wavelength because we are given the velocity. The velocity was 20 meters. So we substitute the velocity, which we are given. We are given the velocity 200, which will be equal to, I want to see that on the question. Yeah. So the wave was 20 meters, and we had to determine the wavelength. We had gotten a wrong answer, which was 0.1. So we substitute the velocity 20 is equals to 0.1 times the wavelength. The wavelength will be 20 divided by 0.1. That will end up giving us 200 meters. The correct answer was supposed to, the correct frequency was supposed to be 0. If the period was 20, the correct frequency was supposed to be 0.05. So if we substituted the wavelength, the velocity 20, the frequency 0.05 times lambda will end up by giving you the wavelength as 400 meters. But this student got 200 as the answer. So you'll get all the marks. A mark for the formula, a mark for the substitution, the wrong answer, and then a mark for the final answer. That's what we call error transfer. Especially questions in transformers, whereby there are several subsections. It is of beneficial to the candidate. Because if there were 3 more subsections, and the first section was probably asking the current, that is in case of the transformers, you'll only miss 1 mark for the first part, but all the other parts you'll get all the marks. So when it comes to error transfer, that's what it means, and it is of help to the candidate. On the numerical questions, we also have the issue where I say we give the units. When we are giving the units, like let's say we have calculated like here we have calculated the wavelength. We know the units are supposed to be, the wavelength is supposed to be 200 meters. When we are writing the meters, it's good to use the correct symbol. For meters, we know it's supposed to be small m. We have the third types of question, the graphical questions. Graphical questions. It's good to note that in the theory papers, both paper 1 and paper 2, we have no drawing of graphs. Graphs are only drawn in the practical paper. The graphs will be drawn for you in the theory papers, but it's for you to answer the questions from the graph. When we are answering the questions from the graph, then the reading should be from the graph. And there must be evidence to show clearly the graph was used. When it comes to the issue whereby the graph is a straight line, then for the straight line graph, then we have to relate with the general equation, that is y is equal to mx plus c. Then when we are working out the gradient, it's good to note that we have to remember some of the factors which might be written on the axis, like given 10 power 14, like we have this example on the photoelectric. This is the question which was there in 2018. The graphs
meaning the three divisions there, each one of them is 2. But from the start, we have
no divisions for 2. So here the argument was the nobody said the graph is starting from the origin. In other words, what I'm trying to say is, when we are doing the exam, you will find a question and see if there is a problem. Remember, those problems are taken care of. The problems are taken care of. So just read what you can see from the graph and work out that particular meaning. Like this question here, we have the frequency multiplied by 10 power 14. The kinetic energy also is multiplied by 10 power 19. The question was to calculate the flux constant H. From the
formula, when you write the formula, that is the Einstein's equation, HF is equals to what? HF naught, that is work function, plus kinetic energy. We make kinetic energy to be the subject of the formula, so that we can compare it with our equations. So we'll have kinetic energy will be equal to HF naught over E minus HF over E minus work function over E. So the gradient is equivalent because we are plotted, the graph is plotted of kinetic energy against frequency. The gradient is H over E. When it comes to the calculation of the gradient, because we have to calculate the gradient, then we get the change in Y over change in X. That is change in kinetic energy divided by change in frequency. But now, it's important to note that when we are calculating this change in kinetic energy, remember the change must be multiplied by 10 power 19. And also in the denominator, the frequency will be times 10 power 14. And then you work out. If you just get the fingers without the powers, for example, you write 3 minus 1 divided by the change in the corresponding change, which might be 4, which might be 6 minus 4. And you don't write the numbers times 10 power. The numerator 10 power 19 in the denominator 10 power 14. Then at that point, the answer is wrong. The examiner will not continue marking. Some of us subtract, and then after that, they now start writing the power. That stage when you are calculating the gradient, the powers must be seen there. So it's good to be very careful when we have the powers, the axis, the quantities multiplied by some powers of 10. Let's take note of that. When it comes to the second part of this question, the question says, calculate or determine the threshold wavelength given the speed of light. C is equals to 3 times 10 power 8. We have the formula that C is equals to lambda 0 times F0. And from there we can get lambda 0, lambda naught, which will be C over F naught. When it comes to writing of this formula, the formula here we are talking of the electromagnetic radiations. So the letter C must be used when you are writing the formula. If you don't use C in the formula, like you write the general formula for waves, V is equals to lambda F, then you will miss a mark for the formula. So it's good to differentiate when we are talking of the speed of light, we must use C. But in these other questions of waves, then we use the general equation for waves, that is V is equals to lambda F. So it's good to note that. From there, we have the fourth type of questions. They are grammatical questions. These are questions which involve or you can resort to sketch.
sketch and graph show an object falling in half. Or sketch the graph. When we are sketching, then label the axis. We also have these other types of questions whereby you can be given a diagram, like this here, or even the generators, the AC and the DC. You can be told to name a particular part, then you state the function of that particular part. We also have the lay diagrams. When you are drawing the lay diagrams, then it's good to note that the lines must be drawn using a jump or a straight edge, and they must have arrows. If you don't indicate the arrows, then those are just straight lines. So the lines must be drawn with a straight edge. If it is in the case of the magnetism, showing the magnetic fields, then it's good to make sure they don't overlap. They must be drawn clearly. On the line diagram, you can have a question, an example of a question. The figure below shows an image of an object on the principal axis in a convex mirror. On the figure, draw a lay diagram to locate the object. When we are drawing the lace here, we have the part whereby the lace must be drawn with broken lines. That is the lace aperture. When we are drawing the lace, if they are lean, it must be continuous. If they are virtual, then it must be broken. So here we have a convex mirror. So we are given an image and we are to complete the lay diagram. So we know from curved mirrors, we have when a quadrant is parallel, it's divergent and divergence are very distance from A. So if we have the real, then we can have it parallel, whereby it is divergent. If it is 2F, you see it is not where the two are meeting, the same happens because the object and the subject. They are meeting at a place where the day is meeting their So the object will go and show apply. When it comes to this case, the arrows must be in the real part, not in the virtual part. In the case you place your arrow in the real part like that, like now this equation put in the match. We look at the first lane, the one you have, I find the one you have is correct. Get a mark. The one you see, we have an arrow at the point where it's not supposed to be. So that one you get. But now the object is correctly at the position where it's supposed to be. So you get a mark for the object. So you end up by getting 2 marks out of 3. So during the questions whereby we have the lay diagrams, then each lay earns a mark, then the object or the image will earn the other mark. If the image is fractal, it must be shown with broken lines. If you draw it with a real line, a continuous line, you'll get 2 marks for the rays, but you'll get wrong for the image. So it's good to note that when we are drawing the lay diagrams. So for the lay diagram, remember you use a straight edge when drawing. We have the next type of questions. Experimental procedure questions. These are questions whereby you are given the apparatus. You are given the apparatus, or you can be given apparatus and you are going to draw a circuit, like in electricity. When you are drawing the circuit, then you have to use the correct convention of symbols. For the potentiometer, we know how to represent it in the diagram, the resistors, and so on. Then you have to check for the workability of the instrument. When we are connecting, like if it's the potentiometer, it's good to note that the potentiometer should be connected across whatever you want to measure the PD. If it's the ammeter, it must be connected in series. So if it's a question to draw a diagram on electricity, the first thing which the examiner will check is to see whether the potentiometer is connected across or the ammeter is connected in series. If it cannot work, then no marks for that. When it comes to equations involving experiments, whereby you have to, it involves changing of variables, and then you record the observation, then clearly state how this will be done, and how you represent the data, and then state clearly how you analyze the data, whether it's through graphical or through calculation. Then if you have plotted the graph, then you need to compute the shape of the graph, Like if it is the Ohm's law, we are verifying the Ohm's law. Then we have to conclude by saying the graph being a straight line through the origin, we can deduce or out that the current is directly proportional to the voltage. When you are given apparatus, then use all the apparatus which are given and don't use your own apparatus, otherwise you'll be penalized. The role of each apparatus should be clearly stated. For example, we have this question from 2016, whereby the student was given those apparatus to draw a diagram, and by convex lens, a lens order, a lead candle, a white screen, and a meter loom. Draw a diagram to show how you would arrange the above apparatus to determine the focal length of the lens. So we have the diagram drawn as it is. You can see we have the candle, which was given. We have the lens, which was given. The lens order, which was given. The screen, and the meter. So everything which was given is taken care of. Then we have the question whereby we have to describe the procedure you would follow. We have the candle placed at a certain distance from the lens. The candle is the object. Then moving or the distance between the lens and the screen is adjusted until a sharp image is formed on the screen. Here the marking point was a sharp image to be formed on the screen. Not just an image, but the image must be sharp. Then take two measurements that you take. Of course, we know we are determining the focal length. So we need to, the distance between the candle and the screen, which will be our object distance. The distance between the screen and the lens, which will be our image distance. Those are the measurements which will be all our variables. So you have 2 marks for that, each a mark. Then after that, you are asked, explain how the measurements in Roman 2 above would be used to determine the focal length. You can try to use the formula, that is 1 over f is equals to 1 over u plus 1 over v. And from there, you compute f, making f the subject of the formula. You can still decide to determine f by drawing a graph. You can draw a graph of 1 over v against 1 over u. You expect to get equal intercept, then we get the reciprocal to get f. Or you can even calculate the magnification, draw a graph of magnification against the image distance and calculate f. All those answers with all those working which can be done, they are taken care of. So use all the apparatus which you are given and don't use your own apparatus. Then analyze or get the correct measurements and then you answer the question. Those are the 5 types of questions we can have in our physics paper. Statement question. The second one is numerical question, graphical question, diagrammatical questions, and finally,
experimental procedure questions.
And with that, I think we come to the end of my presentation. So I ask or I give time for the questions.
Okay. For the question and answer session, if you have a question, then just going to begin the process with GPU. You'll just come in front of your laptop and ask your question from there. Okay?
Yes.
So whoever opens the question can come and ask you a question.